In this video, we'll be taking a look at problems 17 through 24, which tells us to solve each one of these systems using elimination. So the previous video was substitution. We worked through those 8 problems, and now we'll be using elimination to solve these systems. Number 17 has negative x minus 6y equals negative 6, and the other one is negative 3x plus 6y equals 6. So it's nice here for elimination because it looks like in these y's, the coefficients are already equal in number, they're both 6, but opposite in sign. One's negative and one's positive. Well, that's nice because what I can do is just add these two equations straight down. Which will happen is these y's will cancel each other out, and we'll get negative 4x equals, and it happens that also the negative 6 and the 6 looks like that cancels out, so 0. So if negative 4x equals 0, then that means x equals 0. So we automatically have one of our values right there. So if we take that x being 0 and plug it into one of these equations, we'll get negative 0, when we plug 0 in for x, minus 6y equals negative 6. Well, that whole 0 business just goes away, so we have negative 6y equals negative 6, which means y is going to be a positive 1. So then our ordered pair is our x value is 1, our x value is 0, our y value is 1, and the ordered pair is 0, 1. So we're saying those two lines intersect at the ordered pair 0, 1. So if we're going to classify that system, it would be consistent and independent. On number 18, we have this equation here, the system. It would be negative 3x plus 4y equals 9, and 3x plus 2y is 27. Again, it looks like using elimination will be really nice because looking at these x's, our coefficients are equal in number, they're both 3, but opposite in sign. One's negative, one's positive. What that will do for us is when we add these two equations up, these x's will cancel each other out because one is negative 3 and one's positive 3. We'll be left with 6y equals 9 plus 27, which is 36. Then we can divide both sides by 6, and we'll get y equals 6. So if y equals 6, we can go ahead and plug that back into one of those equations. Let's say the first one, and we'll have negative 3x plus 4y, and y is 6, equals 9. So negative 3x plus 24 equals 9, which means we'll subtract 24 from both sides. They'll cancel out here. Negative 3x equals, what's that going to be? Negative 15. When we divide both sides by negative 3, we'll get x equals 5. So we have two values now, our x value and y value. So it looks like our ordered pair will be 5, 6, because our x is 5 and our y is 6. So these two lines will intersect at this ordered pair, 5, 6. And if we're going to classify that, it will be consistent and independent. On number 19, we have this system given here, this negative 9x plus 9y equals 27, and this 18x minus 6y equals 30. Looking at this initially, it doesn't appear that anything's going to cancel out simply by adding these two equations together, but I do see that 9 and 18 are almost that way. If we just doubled this negative 9, then it would be a negative 18 and a positive 18. So here's what I'm going to do. I'm going to put a little bracket around here and put a little 2 up here because I'm going to multiply this whole top equation by 2. So 2 times negative 9x will be a negative 18x. 2 times 9 will be a positive 18y. And then 2 times 27 will be 54. So now if I rewrite this, the second equation under that, it looks like I'm going to have a negative 18x and a positive 18x, which will cancel those two out. I'm going to have an 18y minus 6y, which will leave 12y, and then a 54 and a 30, which will make 84. So when I divide both sides by 12, I should get y equals 7. So now, taking that y equals 7 and plugging that back in for one of those equations, let's just say the first one, it'll be negative 9x plus 9 times my y value, which was 7, equals 27. So negative 9x plus 63 equals 27. Negative 9x will end up being this 27 minus this 63, which should be, what, 36? Negative, because we're minusing the 63. So when we divide that, it'll be x equals a positive 4. So our ordered pair will be 4, 7, because x is 4 and y is 7. So these two lines intersect at 4, 7. And if we were going to classify that, it would be consistent and independent. In number 20, we have this system given. And looking at it closely, we have some x's here and y's. And it looks like my y's will almost cancel out. We want them to be equal in number but opposite in sign. Well, if I doubled this 4, so 4 times 2 would be my 8, and this would be positive and negative, so that would work out. So I'm going to draw my little bracket over here, and I'm going to go ahead and multiply that top equation by 2. So I'm going to double everything, so 2 times this negative 7x will be negative 14x, and then 2 times the 4y will be 8y, and 2 times 24 will be 48. Then I'll go ahead and rewrite the second equation the way that it was. So this negative 14x and then plus 3x will be negative 11x. My y's will cancel out because one's positive 8 and one's negative 8. And then 48 minus 4 will be 44. So it looks like this value of x is going to be negative 4. So I'll take that value of x, which is negative 4, and I'll plug them in. Let's just say the second equation, just for no particular reason. So 3 times x, which is negative 4, minus 8y equals negative 4 will be a negative 12 minus 8y equals negative 4. Can add 12 to both sides, canceling those rascals out. So negative 8y equals, it looks like a positive 8. So y equals negative 1. So again, I have this x value and y value, so I can make an ordered pair out of it. It looks like my answer will be negative 4, negative 1. And that's an ordered pair, meaning that these two lines will intersect at one place, and the place where they intersect is this ordered pair, negative 4, negative 1. And if I was going to classify this system, it would be consistent and independent. In number 21, we're given this system, the negative x plus 5y equals negative 4, and then 2x minus 10y equals negative 8. So it looks like with my x's, they're opposite in sign. This one's negative, this one's positive. The coefficient here is 1 and 2, so it looks like if I doubled that top one, that they'd be the same but opposite sign. So let's go through and multiply this top equation by 2. So I'll get a negative 2x plus 10y equals negative 8. And then I'll go ahead and rewrite that second equation that didn't change. So my x's cancel. Ooh, but it also looks like my y's cancel as well, so I'm left with nothing on that other side. But I do have negative 16 over here, this negative 8 plus negative 8 is negative 16. Looks like I'm left with a false statement. All my variables canceled out. 0 equals negative 16. So it looks like what this is going to do is be no solution. That's what it is here. And it seems like these two lines are parallel. So they have the same slopes, but they have different y-intercepts, meaning they just run alongside each other. They never touch, never cross. So since there's no point of intersection, there's no solution. If we were going to classify this, it would be inconsistent. In number 22, we have the system given by 8x minus 5y equals negative 1, and then negative 7x minus 4y equals 26. It does not appear that my x's or my y's will cancel out easily just by simply multiplying one of the equations by a constant, because 8 and 7, nothing there, and 5 and 4, nothing there. So it appears that we're going to have to multiply both equations by different constants. Looks like my y's are my smallest values, 4 and 5, so let's go ahead and multiply by that. I'll go opposite, so the top one will get a 4, so this goes up there. The bottom one gets the 5. Because when we multiply, 4 times 5 is 20, and 5 times 4 is 20. But I notice right here they both have negatives, so I'll have to multiply one of these things by a negative. Let's go ahead and multiply the second one by a negative. So that'll give my y's equal coefficients but opposite signs. So multiply through, I'll get 32x minus 20y equals negative 4. And then it looks like 35x, and then my x is in there, plus 20y equals a negative, what's that going to be, 130. So my y's cancel. 32 and 35 are going to make 67x equals a negative 134. So So it looks like when I divide both sides by 67, I should get negative 2. So if x is negative 2, I can go ahead and plug that into either one of these equations up top. Let's just do it into the top equation. So 8x, so 8 times negative 2 minus 5y equals negative 1. Negative 16 minus 5y equals negative 1. So we'll add 16 to both sides here, getting rid of those guys. So negative 5y equals 15. When I divide both sides by negative 5, I'll get y equals negative 3. So I have my x value and my y value. So it seems like my ordered pair will be negative 2, negative 3. And that will be the point of intersection of these two lines. So if I was to classify this, it would end up being consistent and independent. In number 23, I have the system here. 10x minus 10y is 0, and then negative 6x plus 8y is 8. Again here, it doesn't appear that I have multiples, so I'll have to multiply both equations by different constants in order to be able to eliminate one of the variables. When I do that, let's go ahead and just get rid of my x's. So I'll multiply up here by a 6, down here by a 10. So that will give me 60x and negative 60x. So those will end up canceling, which is nice. Let's go ahead and distribute that 6 through. So I get 60x minus 60y equals 0. And then multiply the 10 through. Negative 60x looks like plus 80y equals 80. So my x's cancel, which is nice. Negative 60y plus 80y will be 20y equals 0 plus 80, which is 80. And whenever I divide both sides by 20, I should get y equals 4. So that's nice. If that's the case, let's go ahead and plug them in. So I'll have 10x minus 10y, but my y is 4, so I'll go ahead and put my 4 in, equals 0. So 10x minus 40 equals 0. I can add 40 to both sides, so 10x equals 40, and x equals 4. Looks like both my values, x and y, are both 4. So whenever I do my ordered pair, 4, 4, just like that. And since they have a value here, this point, this ordered pair, that means they intersect at 4, 4. So if I were to classify that, it would be consistent and independent. Number 24 is the final problem in this elimination set for the review problems. And 24 is the system given by 3x plus 6y equals 3, and then 5x plus 10y equals 5. So again, it doesn't look like anything is going to be nice multiples, so I'll have to multiply both equations, top and bottom, by something different. Let's go ahead and multiply and get rid of my x's. So 3 and 5, so I'll put a 5 up here and a 3 down here, basically just cross them. But both of these are positive, which means one of these is going to have to be negative, so I'll make my 5 a negative. When I distribute, I'll have a negative 15x minus a 30y equals negative 15. I'll also have a 15x plus 30y equals positive 15. Well, hey, look at that. My x's will cancel, and actually my y's cancel as well, and my constants cancel. So I'm left with 0 equals 0 on both sides. Well, all my variables canceled. I was left with a true statement. So the answer is going to be infinite solutions. What this means is these two lines are the same exact lines, and we call them coincident, and they just lay on top of each other. So they essentially intersect or cross or like at every point. So there's an infinite number of points because they are the same line. They are on top of each other. So we call that infinite solutions. If we were going to classify that, that would be consistent and dependent.